Welcome to Utilizing Tech, the podcast about emerging technology from Gestalt IT. This season of Utilizing Tech focuses on edge computing, which demands a new approach to networking, storage, compute, and more. I'm your host, Stephen Foskett, organizer of Tech Field Day and publisher of Gestalt IT. Joining me today as my co-host is Alistair Cook.
Hi, I'm an independent analyst and trainer and based here in beautiful New Zealand.
And Al, you and I at Edge Field Day and on previous episodes of Utilizing Edge have had this quite a lot of conversations about what you called the far edge. Today we're going to dive a little bit into the near edge. So talk to me a little bit about those definitions in your mind.
Well, this came from writing about infrastructure solutions at Edge, in particular hyperconverged infrastructure. And it became apparent to me that the edge isn't the same thing to everybody. And I had vendors who would normally tell me about data center infrastructure products, telling me about how these were edge products. And I had other vendors with really specialized hardware that you wouldn't put in a data center telling me that these were edge products. And it became clear that there isn't just a single edge. And in my mind, I had the separation of those two kinds of products. So I had the idea of a near edge as something that's closer to your central data center and is more data center-like. So it's got power protection, it's got environmentals, but you probably don't own it. So it may well be a co-location in somebody else's point of presence. Whereas the far edge is actually somewhere you own and that you're putting your infrastructure into, but it's nothing like a data center. At the previous episodes, we've seen things like Brian talking about Chick-fil-A and having edge deployment into quick service restaurants. This is very different to deployment into data centers. And so I definitely saw completely different solutions for those two different problems. And as you say, we've been talking mostly in the podcast and at Edge Field Day about the things that go into your own data center or your own non-data center locations, your stores, your gas stations, your trucks. But that's not all that Edge is.
No, in fact, I think that there are a few different definitions that we've seen in the industry, and certainly there's a few different categories of products, and not all the products are for quick serve restaurants or oil rigs. A lot of them are, network edge, as you say. And one of the people that really knows this topic is our guest today, Andrew Green, who is a research analyst at GigaOM, like yourself, and who focuses on edge. So welcome to the show, Andrew.
Hi, Stephen. Hi, Alistair. Thanks for having me.
So talk to us a little bit about your focus at GigaOM and your own personal interests in edge and your reaction to what Andrew just said about the near edge versus the far edge.
Sure. Thank you. So my name is Andrew Green. I'm a networking and security research analyst at GigaOM, and I'm also the director of Precision.co. In terms of edge, I was kind of pushed to it, so it was really a natural evolution of getting there. Within GigaOM, we've really defined a couple of reports for edge, the main one being edge platforms, which is essentially a take on an evolved CDN. It started off as an evolved CDN, and then we matured the space into its own solution. So it is matching the definition of far edge, like Alistair mentioned, and from that scope, what they usually define as edge, and it really covers wide distances at this point, is whatever can get you workloads in 20 milliseconds round trip. And in terms of distance, that actually equates to 1,000 miles. So, for example, if I am sat here in the UK and, for example, I have a server in Germany that I'm talking to that might be 1,000 miles away, and I still get 20 milliseconds round trip, I will still classify that as edge. And the reason for the 20 millisecond threshold is because that's the point when you can actually physically feel that something is delayed or not. And that's very obvious for anybody who plays instruments. Like whenever I was playing guitar and I was recording something, if you have a delay of more than 20 milliseconds, you can't actually play. It feels awkward. It feels a bit weird. So that's the reason for the 20 millisecond definition, and that's usually applicable across all domains that record that real-time interaction.
So I'd characterize that 20 millisecond delay as being about the near edge. So it's closer to It's further away from the actual user than my definition of far edge. Far edge, the person that we're targeting is actually standing close to, and we're down to a few microseconds of latency. So this content delivery network and then evolving services beyond that is, for me, very much what the near edge is about. It's locations where you're putting relatively heavyweight applications that are used by a diverse collection of clients. And it really does feel like that's a huge use case for a lot of organizations that are delivering over the internet or over a 5G network now, delivering a service to their end customers. And that latency absolutely is a killer. You can't cure latency other than by putting the compute closer, or the service closer to your users. You can't buy lower latency the way that you can buy higher bandwidth. And that's a common mistake as people doing system architecture, is to think you can cure all of your performance problems simply by getting more bandwidth. But the speed of light, that propagation delay in the electrical signals, is a reality that you can't buy your way out of. You've got to distribute your application to suit that.
Yeah, that's exactly right. And hand in hand with this also comes geographical distribution. So at least from a CDN perspective, or it can be data centers for cloud providers, or it can be telecommunication service providers, anything that has a distributed infrastructure. You can deliver services globally. So, for example, if I have some points of presence over in North America and have some over in Oceania and then in South America, it's all kind of a unified edge fabric, and it all depends on the vendor's ability to deliver services closer to the end user within that 20 millisecond threshold that I talked about.
Yeah, it does, I think, depend on the perspective as well, Al, whether you're talking about near edge, far edge. Near to whom is, I guess, the question. But I think what you're getting at there is definitely something that we've been hearing about from many different companies. You mentioned CDNs, Akamai, Cloudflare. We were also, I was talking to a company, EdgeGap, that's talking about deploying gaming closer to players to overcome exactly the same thing that you're talking about here. That perception, that feeling that if latency is too high, then interactivity drops. And it's almost like an uncanny valley, isn't it, with applications that as soon as you get past a certain threshold of latency, it's no longer real time. It just doesn't feel real time. And that's your 20 milliseconds, right, Andrew?
That's exactly it. Computer games are actually a huge use case for this, because it's essentially the definition of having to interact with something in real time, and we see real world deployments of this today. So we're not talking about something that's a few years down the line. It's happening today, and to be fair, especially with computer games, whenever you had to pick like a server that you're playing to, and the one that was closest to you was very busy, so you had to pick one that was far away, like maybe across the ocean or something like that, you were always at a disadvantage. And today it's not the case anymore. So I think it's a huge win in that industry.
So how is it not the case anymore? I mean, it can't be just that people are playing with local players. There's got to be technical solutions that are going out, and I know that that's something that you're really focused on. So tell us, how do people bridge this edge? How are people getting past this 20 millisecond threshold?
In terms of what used to happen maybe 15, 20 years ago, you used to have some servers that were in major metropolitan areas, but if you're further away, you just didn't have access to it in the latency that you can actually play competitively. So this time, with the distribution of points of presence, I mean, for example, across especially North America and Europe, but typically across the world nowadays, you have something that might be just a few hundred miles away from you. In terms of what can you actually deliver, each of those points of presence now essentially behaves like it's slightly like its own cloud entity, so you can have compute and storage on there. So you don't necessarily just do caching like you used to do with content delivery networks. Now, within compute and storage, you obviously have a multitude of technologies that you can use. You can have bare metal at the edge, you can have virtual machines, you can have Kubernetes, you can have function as a service. So the type of technology that you want to use at the edge really depends on the types of use cases. And the types of use cases that I've seen most popular are for web performance and application delivery. So, for example, can I get modern website architectures? Like, what can I do with server-side rendering, personalization? A lot of companies are interested in doing A/B testing, and those are really use cases that are applicable through those new types of compute that is available at the edge.
And that compute might be something as simple as the Lambda at Edge component that AWS has added to CloudFront, or Cloudflare have their functions as well, haven't they? But it might also be that you're building your own infrastructure, as you say, building out an infrastructure to run a Kubernetes cluster at each of these distributed edge locations. Given that they're within 1,000 kilometers of a user, then we're probably talking about hundreds of these data centers around the world rather than thousands or just tens of them. So in terms of the scale of this is a relatively large implementation, so something like Kubernetes does suit it quite well. As you say, functions as a service, we really like running serverless components for these scale-out applications. That seems like a really good fit to the sort of use cases of accelerating applications and essentially delivering the application much more locally to the user.
Yeah, absolutely. And within this, there's also each of those lighter points of presence actually have limitations in terms of what you can do, and in terms of where you actually want to deliver the service. It might be like a very remote point of presence on an island where the service might not be accessed. If you have a persistent virtual machine or even bare metal there, it might be just wasted money after all. So having something like serverless and functional service where you can just spin up the service, deliver whatever you have to, and then spin it down, it might be much more cost effective. So those edge compute technologies really have real use cases today. But I've also seen in the market that when people talk about the edge, they go like very well beyond what's being delivered today and talk about stuff like remote surgery, connected cars, and all of those use cases that are pretty far out there. And I made the analogy that it's a bit like thinking of use cases for a brick. So, for example, I can use a brick to crack a coconut or do whatever with it, but that doesn't mean it's the most efficient way of doing it and what you're supposed to do with a brick, right?
So let's think about where these things are being deployed, and I think again, there's sort of a frontier here where, on the one hand, you are deploying them in a service provider, globally distributed service providers locations, as Alistair said, maybe hundreds of locations even around the world. And then there's, I guess, another completely different step. I get like a quantum leap where you would deploy these things everywhere, very, very close to users in literally thousands, tens of thousands, hundreds of thousands of locations, right? And then there's even another quantum leap where this stuff is deployed locally in either retail or industrial locations, or even in the hands of end users. And I can see each of these different states being interesting, offering distinct benefits. What's real though? Is it possible to deploy this stuff, for example, on every block in every city around the world? Is it possible to deploy them in every 5G point of presence, or is it something that at this point we're talking about deploying hundreds of locations around the world at the premises of a service provider?
That's a great question, Stephen. And to be honest, I think it all comes down to economics and financials, right? So you can have those types of compute and storage capabilities very close to the end user. I mean, by definition, edge is you're looking at the topological edge of a network. So that can be your home router. It can be your the first hop in your last mile provider, for example. So those edges can be essentially deployed anywhere. And now it's a matter of what do you actually want to use it for and what makes sense financially. So for example, if I have like very intensive compute storage transfer requirements like big data analysis, the type of AI and machine learning we've all heard and love, you want those to be not necessarily distributed everywhere because they don't make sense, but having that near edge, if you have to have the um, processing locally, so you don't transfer over like terabytes of data across 1,000 miles, that might not be cost efficient. You might just want to do it locally, have that distributed as much as it makes sense. But for example, with telecommunication providers, considering like the internet is a commodity at this point, they need to invest into something. So I wouldn't necessarily be surprised if we'd have every radio mast to be enabled with some sort of like edge compute capability. What you do with it at this point, I'm not entirely sure. Will it be more cost efficient to do, for example, all the network intelligence, like network slicing and monitoring on the edge at the mast rather than doing it centrally? I'm not entirely sure, but it's definitely something that can happen.
We are, though, seeing real-world use case for these things of distributed networks for delivering gaming and for delivering media. We're seeing telcos who want to deliver video on demand to their customers, who are putting the compute really close in that 20 millisecond round trip distance from the customers. And some of it's driven by the 20 millisecond round trip, but some of it is about that economics of transferring large amounts of data. And that's one of the reasons why we also see far edge deployments. Things like doing video surveillance in your store. You don't really want to stream that video back into some central location to do analytics to it, but you want to retain the video and you want to do some local analytics, maybe for fraud detection, on site. So there is absolutely that separate sets of use case, and whilst latency is a big factor, cost of data transfer, that bandwidth that you're paying for to get more data transfer, that's expensive, particularly if you're going out to hundreds and thousands of sites. So there are a lot of real world current use cases for putting compute where data is generated or getting data closer to the users. And that's where things are definitely delivering value right now. I think there is a huge future capability around having a more generic platform, particularly at the near edge in those data center like locations, that is more cloud like. And we're seeing more of that distributed cloud turning up out of normal cloud providers. Andrew, are you seeing more cloud like services being delivered in these distributed locations where it's on demand consumption, or is it still very much about a bespoke application being delivered into those locations?
Yes, it's very much cloud-like behavior, and essentially it really comes down to the scalability of a solution. And I really love the video processing at the edge. For example, you might want to do like human detection, and you also need to keep in mind stuff like increase of data generation. So, for example, at the moment, I'm not really sure what the surveillance the resolution for surveillance cameras is, but I wouldn't be surprised to see it increase to like 4K and 8K, right? So that means that you need to have adequate capabilities to not only store but also process the data at the edge. And this is where the cloud-like behavior needs to come in. How can I optimize those locations such that, as we mentioned previously, I don't have a bunch of resources that sit idle, but I also have the scalability on demand. And for example, you can borrow concepts like cloud bursting, where you can have some core capability that you have to do, and if there's a spike in demand, even with the forfeiting the 20 millisecond rule, you can just offload some of the workloads to the cloud or to another edge location and get it back, and still essentially retain some sort of performance. But having that scalability is really difficult. And another thing that I saw vendors, and one of the new metrics that I defined in the Edge Platforms report, is about multi-environment networking and compute orchestration. So, for example, what I mean by that is if you have some sort of edge provider, they can integrate usually via APIs to spin up, spin down, and configure other compute resources in other environments. So, for example, I might use, Cloudflare at the edge and then do some sort of processing there. But then I need to have um, also an AWS EC2 spun up somewhere to run maybe some application that I imported. Would Cloudflare be able to orchestrate to give the developer a single pane of glass or a CLI or some sort of IAC integration to spin up that AWS environment such that they can communicate between each other? You can organize that cloud bursting. You can make sure that it's seamless connectivity. You don't have to mess about with firewalls and still do it securely. So it's definitely a lot of work, and I think edge platforms have an opportunity now to have this overlay fabric controlling not only their own infrastructure but also other types of infrastructure, including those that you own on premises infrastructure, colocation, managed hosting, private clouds, and so on.
Yeah, this is an interesting concept because what I think we're getting at here is the idea of basically an abstracted edge platform that would span from the near edge to the far edge. At least that's what it seems like to me. Or am I off base? Because as you mentioned, certainly state of the art in security cameras now is probably 4K with 8K coming. We've seen the recent at the OCP summit, we saw the introduction of a new edge router that can handle, massive bandwidth, because they're talking about having like literally hundreds or thousands of 4K cameras deployed at these remote locations. Clearly, that's going to require local processing. But they're also, this is Amazon. And so they're talking about integrating that with near edge, with the cloud, and having sort of a unified platform. And as you mentioned, services like Cloudflare. Does this mean that we're going to have some sort of new platform for running these applications? And if we do we have that, or is that still being developed?
I think that we are very early days, but that seems to be the direction that we're going in. For example, somebody like AWS that also have their own CDN, not to mention all the globally distributed data centers and the very comprehensive portfolio of products. They have a lot of power to do stuff. It's going to be a matter of orchestration as well. There is also a note about edge routers, the actual routing appliances that can host compute such that they can host some sort of application. The technology already exists now that you can have like your firewall hosted on the edge router, but there is no reason to have that routing appliance, which is by definition what the edge is. It's the routing appliance at the edge. They're called edge routers. To actually have the compute and storage capability to support those types of use cases.
And we've seen these intelligent routers with the ability to run essentially virtualization at the edge for a while. What I think we're seeing is a shift towards them being a general purpose tool, not a special purpose tool that you can run multiple applications on. The other compute that's interesting at the edge is the actual cameras themselves. A bunch of the security camera products are actually doing AI functions directly on the camera, so you don't even store when there's no change in the video. You actually only store the segments where there's change in video, and that again shifts what data is coming into the edge location and gets that processing closer and closer to the data generation. Andrew, are we seeing that unified platform that we all dream of to give us, heaven forbid, a single pane of glass for managing this entire thing?
Not at the moment, and to be honest, it seems that the further we go towards the edge, the more we go back in time, where all the data is going to be processed locally, and then you just have to integrate the outsourced infrastructure services into it, essentially. But what I have noticed is that some of the edge platforms that I featured in the recent GigaOM report are integrating both far edge and near edge in their offerings, and they don't all do that. So I defined three types of deployment models. So you can either have your on demand, your existing points of presence, on demand points of presence. So upon customer request, can the vendor actually spin up a point of presence somewhere near to that location, or can the vendor support either via dedicated hardware or a virtualized hardware the services that they deliver for that customer. So, for example, I can have a purpose-built hardware shipped to the customer. They install it in their whatever location they want, and they can have those types of services that include application delivery and then load balancing and so on that hardware appliance. Or it can be a virtual appliance, can be installed on a all-purpose server, and it still integrates with the wider edge platform offering to have content delivery, video streaming. It can be whatever.
Yeah, it's really exciting to think about that because we've talked about this a few times, Alistair, where, as you said, local processing it almost acts as a filter. So you have a tremendous amount of data that goes through a local, very hyper-local filter, local to the camera or sensor. Then the interesting stuff is downsampled and sent to the next level for processing, and then that's downsampled and sent to the next level for processing, and so on. And it really is one of the fundamentals of distributed computing, right? And also, I mean, at the risk of getting tomatoes thrown at me for bringing up an old podcast topic, the rise of tensor processing and machine learning processing is just amazing, and the technologies and the tools that we heard about in seasons 1 through 3 of utilizing tech. Companies that are developing, TensorFlow processing on ARM chips, on x86, Brain Chip, for example, that's trying to do this with low-powered chips. All these companies that are trying to basically build machine learning-based filters for all of this data in order to make it possible to process this. I'm sorry, I'm just getting excited. I guess that's I had to bring up AI. I had to bring it up after all of this. But I think you're right. I think that there is a lot of work being done with this, Alistair.
Yeah, and one of the concepts I had was the idea that the edge was about being a data refinery, that where data is being generated at the edge, we improve the value of the data as close to where it's generated as possible and then pass it on for the next phase. And I think that's one of the things that tends to characterize the far edge, where it's at a location we own and where we've got our cameras, that's generating the data and sending it back into central. Whereas I think near edge feels the other way, that the data is being generated in some central, often cloud location, and then being pushed out to that near edge location. And that's just something that struck me today. Now, there's always a hybrid. Because if the far edge location is a gas station and there's advertising and video advertising being delivered, then there's data flowing outwards. But the refinery aspect sort of comes back in the other direction, which is interesting.
That's actually a great point, because if I think how we initially defined this edge platform report from a content delivery, that's exactly what you're saying. You're delivering content from some sort of central server, like it might be a website, it might be video, it might be images, it might be whatever, so you're delivering that. But at the same time, when you have data generated on location, and then you need to do it and then send it somewhere, let's say in the cloud or to some of your infrastructure that hosts it somewhere else, then you need to have that processing kind of the other way around. And with the risk of opening up another kind of forums, I'm thinking about the security aspect of it. So, for example, the more data you generate, the more you have to store it. But then, when you store that data, what's your retention policy? If data you have some sort of attack that's happening on location, would you actually risk throwing that data away, let's say after 3 months, if it was infected, and not be able to, work back to see how much, what was the impact on the business? I came across a recent IBM report that said it's about 273-day average for a threat to be identified. So I'm wondering, if you're generating all this data on the edge, how much of it do you store, because it's going to be more and more data. So what's your take on it?
I definitely think less and less storage is going to be what's going to happen. We're going to collect more data. We're going to store less of it. We're only going to store the interesting bits. What do you think, Al?
Well, I think the reason we've stored lots of data in the past is we had no idea of the value of that data. This is what drove the explosion of big data. As we start applying AI and machine learning to it, we find the actual value in the data. And I think you're right that we will start throwing out the data of unknown value when we can actually identify value in data. And that idea that all data is equal and all data should be kept forever because we don't know what value it has. We need to shift away from that. It just doesn't continue to work.
With you saying that, it also led me to think that we can also apply AI and machine learning for threat detection at the edge, such that if we want to store data, then we can as a business choice. But if we don't want and we risk losing that information, then at least we can apply some sort of real-time threat detection at the edge, such that when we get rid of the data, when we discard it, it's not going to be a business risk as well.
Yeah, and that's actually one of the things that machine learning is really good at is threat detection and determining basically what to focus on and what to ignore and what to skip. And that was one of the things that came out of a lot of our discussions earlier. And I agree with you. I think that's really something that is going to be very, very valuable and in fact necessary because of this flood of information. So before we go, I want to kind of return to the first question that I had, which is, Alistair, you've been talking about near edge and far edge. We've been kind of dancing around this with a lot of conversations so far about building a lot of far edge stuff. Now that we've had a chance to talk near edge and to talk about this continuum, do you have a different opinion on this, or has this just cemented that opinion?
I think for me, what I think I learned today was that in business, you always say follow the money. At the edge, follow the data. It's all about getting that data close to your users, and there's different definitions of getting that data close to your users or the processing close to the data. I think that's what I learned today.
Andrew, how about you? Thank you so much for joining us. What's your summary? What's the takeaway message for folks listening to this?
Thank you for having me, Stephen. And the I think the biggest realization is the one that I had just now about either pushing data from the edge or pulling data from the edge, and those use cases between near edge and far edge, and how they can, essentially have different use cases. It's not only an architectural concern, but it's also a business concern, a security concern. So whether you push data or you pull data from the edge, they're completely different systems, and they should be treated accordingly.
Absolutely. And I think that we do also need, as we've kind of been dancing around in here, some unification in terms of the platform, in terms of orchestration and operation, deployment, security. All of these questions are going to be coming up. And I know there's a lot of companies working on that. And I'm really excited to see what the two of you at GigaHome and the rest of the industry come up with in terms of structures, descriptions, overviews of all of these solutions. Those of you listening, thank you very much for joining us. Where can those people continue this conversation with the two of you? Andrew, I'll give you a chance to go first. Where can we find you and continue this conversation?
So you can find me directly at precisem.co, or you can send me an email at andrew.green@precisem.co, where we deliver technical content writing for enterprise IT.
And you can find me, Alistair Cook, as at DemitasNZ on Twitter or demitas.co.nz for my own thoughts and writings about this. You can also find me in person at VMware Explore very shortly, or a few months' time. And I definitely suggest checking out some of the vBrown Bag and Build Day Live videos that we've created around data center infrastructure primarily, but maybe some edge infrastructure coming soon.
Also, I think I don't want to put the cart in front of the horse, but I think it's pretty likely that the three of us may be involved in Edge Field Day going forward. So I hope that we have all of us involved in that, and that people will be able to see us there. You can learn more about that at techfieldday.com. And of course, you can find more from me by going to gestaltit.com and checking out the On-Premise IT podcast or our weekly news rundown. Thanks for listening to Utilizing Edge, part of the Utilizing Tech podcast series. If you enjoyed this discussion, please subscribe in your favorite podcast application and consider leaving us a rating or a nice review. This podcast is brought to you by GestaltIT.com, your home for IT coverage from across the enterprise. For show notes and more episodes, go to utilizingtech.com or connect with us on Twitter or Mastodon at Utilizing Tech. Thanks for listening, and we will see you next week.